We're approaching the end of videos on object-oriented programming in Python, and we're going to, in this video, look at one of the major topics for object-oriented programming, encapsulation, or nowadays it's sometimes called information hiding. Depends on one's point of view, I guess. So what we're going to learn about in this context is private, protected, and public variables. Private means that only the class that the variable is declared in should have access to it. Protected means that the class of the variable is declared in, and any subclasses should have access to the variable. And public means that anybody in the world can use it. So we are going to look at how Python implements these ideas. Now, be clear from the beginning that Python in some ways actually doesn't implement these ideas. These ideas are somewhat anti-Python in a sense that the idea behind encapsulation or declaring variables to be protected is essentially that programmers are dumb, that they shouldn't have access to your class variables. So this is the original motivation behind using protected and private variables. That is not the way that the original author of Python and still the maintainer of the Python language views the world. He views programmers as being intelligent. So he thinks that they should in fact have access to variables. So the point of view from Python is that if you declare a variable to be protected or private, then what you're really telling the programmers that's looking at your code or using your code is you shouldn't access this variable, but if you really need to, go ahead. That's contrary to some other languages where you can declare a variable to be private or protected, and you literally cannot access that variable outside of the class or perhaps a subclass if it's protected. So it's a little bit hard to talk about these topics using Python because they're not in fact enforced and used the way that they are in some other languages. So to really learn about these issues, in some ways you'd have to go to a different language like C++. But Python is what we have, so we can hopefully give you the general flavor, which is more along the lines of the idea with encapsulation in Python is more that you have data, but you also have methods for acting on that data. So, all right, let's go into some specifics here for Python. So I've created a class, privacy. It has three variables: a public, a protected, and a private variable. So to make a variable protected, you just put an underscore in front of it. And to make a variable private, you put a double underscore in front of it. And that's it. So in this init, I've just declared these three variables, and I've initiated them all to be 1. And then I have a string method which prints those three variables out if you ask it to. So it prints out the public, the protected, and the private. Note here that the names public, protected, and private are not important. What's important is do they have an underscore before them or not. So we have made plenty of classes with public variables where we didn't put an underscore here, but you can put an underscore or a double underscore in front of your variables, and that changes how Python views them, or it should change how programmers view them. All right, now down here I've instantiated privacy, and I've called it experiment. And I've asked to print out experiment, and what I should find out is that public is 1, protected is 1, and private is 1. Now, after I've printed those out, then I've redeclared what those variables are. So I tried to make public, or I'm trying to make public 2, I'm trying to make protected 3, and I'm trying to make private 4, and then I'm going to print those out again. And in this case, I'm printing out the class, but here I'm printing out experiment double underscore private separately, and we'll see why that's the case after I run this. And then down here, I'm making this weird variable 5. So let's run this, and let's look at the output, and then we'll see perhaps what's going on here. So I'm going to run private variables, and let's look at the output from the top. As expected, when we do the print experiment, because of the way this thing is initiated, we expect public to be 1, protected to be 1, and private to be 1. So no issue there. Now we change them to 2, 3, and 4, and we again print experiment, and what we find out is that the public in protected are both changed, but the private is not changed. Interesting. And what's more is we find out that experiment _private is changed to 4. So this is kind of strange because we should be setting, when we do experiment _private equal 4, we should be changing this attribute for the object to be 4 right here. But when we print it here using the string method, it prints self._private and prints a 1. But then when we print experiment _private, it prints a 4. So this is kind of strange. So what's happening here? Well, okay, so Python doesn't enforce protected and private variables the way other languages do. In fact, in other languages, if I tried to access this private variable, I wouldn't be able to do this at all. In fact, up here, instead of using a double underscore, I would say something like protected or private. I would put an attribute on the variable, and I wouldn't be able to use it here at all. I just wouldn't be able to touch it. So Python doesn't enforce protected and private like other languages do. So what does it do? Well, it uses I guess a clever way of enforcing privacy. It does something called name mangling. So up here we have declared this variable as self._private, but internally, because this has a double underscore in front of it, Python says, okay, so you want that to be a private variable. Fine. What it does is it actually gives it the name single underscore class name double underscore your variable name. Whoops, I didn't want to do that. Stop. Well, I don't know what I just did, but okay, didn't want to do that either. My goodness, what is this thing doing? There. Let's try that again. So internally, Python is calling this private variable through name mangling. Again, single underscore, the name of the class, which was privacy, and then the double underscore private. So you can actually change this variable directly, even though it's supposed to be private. And again, in other languages where you declared a variable to be private, you wouldn't be able to do this. But in Python, if you know how name mangling works and you know the namespace, you can do this. So in Python, you're on your own recognizance in a sense. You should not do this unless you really, really have to for some reason, but you shouldn't because it's been declared private by the person who created the object, if that makes sense. So after making this change, I'm again printing experiment and printing private, and what we find out is that now when we print this out, public and protected are 3, as we expected from above, but private, that's self._private, is now changed to 5. So we have accessed that private variable, even though perhaps we shouldn't have. So what is this? Well, when we declared this to be 4, go over here, I got a PEP. Unresolved attribute reference _private. So it's saying, when it says unresolved attribute reference, it's saying, I don't know what this variable is. You've declared experiment to be of type of class privacy, but in your init, you have never declared a variable _private. Well, we just declared _private right here, so why isn't it recognizing it? Again, because _private is name mangled to this, and this variable actually doesn't exist. So when I declared this to be 4, Python actually added this attribute to the class, a _private, and so when we're printing this separately, we are still getting this 4. This is actually a different variable than this, whereas this is the same variable as that. I hope that makes sense. But that is the way Python handles private and protected variables. Now in terms of subclasses, the way this should work is that if you have a protected variable, you should be able to access it in any subclass. So this is class privacy, the exact same class we had in the previous example. And then I've just subclassed privacy, and I haven't done anything different in the init. I just call this init up here, so it'll set those to 1. And remember to call this init, we do super.init. And then I've changed right after that the public to 2, the protected to 2, and the private to 2. But because of the name mangling, remember this name actually is not this, so this won't change. In terms of printing out a string for this, we have the same variables, public, protected, and private, as we do up here. So I'm just using this string method up here, super.string. I instantiated the subclass and printed it, and what we're going to get is 2, 2, 1, because again, this doesn't change. In another programming language that enforces the protected and private, this subclass would have access to protected, but not to private, and that's the way it would be enforced. Okay, so what is this idea of encapsulation then? If you don't have access to these variables without undoing the name mangling, how do you interact with these variables? How can you do it? Well, encapsulation, then, one view of it, and particularly the Python point of view of it, is that you have data, but along with the data you have methods for acting on the data. So we're going to get into something called getters and setters. Alright, now this is a new class, triple. I've changed the variables around just to make it clear that when we're talking about these variables, it's not the name of the variables that matters, it's the number of underscores. So this has 3 variables, x, y, and z. This one is public, this one is protected, this one is private because of the underscores. I am printing them out in parentheses and commas separating them. So I'm printing these out in the string method. And then I have what are called getters and setters for those 3 Oh, I didn't do x. How did I not do x? Well, I guess it doesn't matter. I have getters and setters for y and z. Get y just returns a value for y. Oh, I guess I don't need a getter and setter for x. It's a public variable. That's why I didn't do it. Know your own video. Get y just returns the value of self underscore y, and set y. You can set then the variable underscore y to any value that you pass into set y. Get z, and set z are similar in the sense that get z returns the value for double underscore z. So now you can print out the value for this private variable, and you can set it. So inside the class, I can reference that variable self.double underscore z. So I can pass in a parameter z here and set self.underscore z to that using set z. So attributes, and then methods for acting on those attributes. Declared a point, triple. So x is going to be 1, y is going to be -1, z is going to be 2. I'm going to print that point out. I'm going to get y and then print out y, so I should get a -1 from this. So point is an instantiated version of triple. So if I do point.getY, I am calling this method right here, which just returns self.underscore y. I'm going to set y and z to be 3 and 4. If I want to change x, because it's public, then I would just do something like this. It's only y and z that are, again, protected and private. And then I'm going to print them the point again. Okay, so I'm going to run this. And here's the original point, 1, -1, 2. I can get any of the values I want, even though these are protected and private variables. I can get a value. I can get the value for y and z using the get function. That gives me a -1, and I can change the values using the set methods. So I can change y and I can change z like that. So at this point, you should be a little bit confused, because we made this big deal over here about how you can't change private variables without doing name mangling. But here I'm saying, well, you can make this thing private. Go ahead. but then I'm going to provide a setter for you so that you can change the value of it. So you really should be wondering, what in the world is the point of this, of making something private or protected, if you're going to go ahead and provide me a way to get the value of it and change the value of it? Why wouldn't I just make it public? That is an excellent question, and a question that we are going to answer in these 4 pieces of code right here, why part 1, 2, 3, and 4, in the next video.